What if I told you that everything you've ever known, every star you've seen, every person you've loved, every moment you've experienced might exist inside a black hole? This is a possibility that some of the world's leading physicists take seriously. Right now, as you watch this video, you and I and everyone on Earth might be living inside the event horizon of an unimaginably massive black hole. If you're ready to question the very nature of reality and explore one of the most profound mysteries in cosmology, hit that subscribe button and give this video a thumbs up. Now let's begin. The idea that our universe might be inside a black hole isn't just a random thought experiment. It emerges from the strange similarities between black holes and our cosmos. When physicists like Poplawski from Indiana University and Lee Smolin from the Perimeter Institute started comparing the mathematics of black holes to the mathematics of our universe, they found something astonishing. The equations match up in ways that seem too perfect to be coincidence. Let's start with what we know for certain. A black hole forms when a massive star collapses under its own gravity. The collapse is so complete that it creates a region of space where gravity is so strong that nothing, not even light, can escape. The boundary of this region is called the event horizon. Cross it, and you're doomed to fall toward the singularity at the center. But here's where it gets interesting. In 1960, physicists Roy Kerr and Ezra Newman discovered that rotating black holes, which are what most real black holes are, don't necessarily have a point singularity at their center. Instead, they might have a ring singularity. And according to general relativity, if you could somehow pass through this ring, you wouldn't be crushed. You'd emerge into somewhere else. This somewhere else is what physicists call a white hole, a time-reversed black hole that spews matter and energy outward instead of sucking it in. And here's the kicker: the Big Bang, the event that created our universe 13.8 billion years ago, looks remarkably similar to what we'd expect from a white hole. Think about it. The Big Bang was a moment when all the matter and energy in our universe erupted from an incredibly dense point, expanding outward at tremendous speed. That's exactly what a white hole would do. Could the Big Bang have been our universe being born from the other side of a black hole in a parent universe? The mathematics supporting this idea comes from Einstein's theory of general relativity itself. When physicists extend the equations that describe black holes, they find that the interior of a black hole could contain an entire universe, not a small universe, a full-sized cosmos like ours, potentially infinite in extent from the perspective of anyone inside it. Dr. Poplawski published groundbreaking papers in Physics Letters B, showing that the torsion of space-time inside a rotating black hole could trigger a Big Bang-like expansion. His calculations suggest that every black hole could birth a new universe, and our universe could be inside a black hole that exists in an even larger parent universe. This isn't just theoretical hand-waving. Poplawski's model makes specific predictions that we can test. For instance, it predicts that our universe should have a slightly preferred direction of rotation inherited from the spin of the parent black hole. Remarkably, some observations of galaxy rotations hint at exactly this kind of universal preference, though the data is still being debated. The Event Horizon Telescope, which gave us our first image of a black hole in 2019, has shown us that black holes really do have event horizons, just as Einstein predicted. The supermassive black hole in galaxy M87, which has a mass of 6.5 billion suns, showed us the glowing ring of superheated matter circling the point of no return. If our universe is inside a black hole, we're seeing smaller versions of the same phenomenon that might bound our entire cosmos. But wait, you might ask, if we're inside a black hole, why don't we feel the crushing gravity? Why isn't everything falling toward a central singularity? This is where the beauty of Einstein's relativity comes in. From inside a black hole, space-time can look perfectly normal. The falling happens in a dimension we can't directly perceive, time itself. In our universe, everything is indeed falling, not through space, but through time, from the Big Bang toward the future. The expansion of our universe might be the four-dimensional equivalent of matter falling toward a black hole's center. We don't feel it as falling because we're all falling together, just like astronauts in orbit don't feel gravity, even though they're constantly falling around Earth. The observational evidence for this wild idea keeps mounting. When we look at the cosmic microwave background, the oldest light in the universe, released just 380,000 years after the Big Bang, we see tiny fluctuations that eventually grew into galaxies and galaxy clusters. These fluctuations match what we'd expect from quantum effects at the moment of a black hole collapse. Even more intriguing, the overall flatness of our universe is exactly what we predict if it exists inside a black hole. Measurements from the Planck satellite, launched by the European Space Agency in 2009, showed that our universe is flat to within 0.4% accuracy. This flatness is natural if our universe is the three-dimensional surface of a four-dimensional black hole interior. Lee Smolin, one of the pioneers of this idea, proposed an even more radical extension called cosmological natural selection. In his theory, universes reproduce through black holes, and each baby universe has slightly different physical constants than its parent. Over cosmic time, this would lead to universes that are naturally fine-tuned to produce lots of black holes. And coincidentally, the conditions that produce black holes also produce stars, planets, and life. This could explain one of the deepest mysteries in physics: why our universe's fundamental constants seem perfectly tuned for complexity and life. If universes evolve through black hole reproduction, then we'd naturally find ourselves in a universe good at making black holes, which requires making stars first, which creates the heavy elements needed for planets and life. Now, to truly grasp the mind-bending scales we're talking about here, you need to understand just how vast our universe really is. If you want to explore the incredible size of the cosmos, from Earth to the observable universe's staggering 93 billion light-year diameter, check out my video called How Big is the Universe?, where I break down the true scale of everything from our solar system to superclusters and beyond. Understanding these cosmic scales makes the black hole universe theory even more awe-inspiring. The link is in the description and on the card above. Now let's continue. The Large Hadron Collider at CERN has been searching for microscopic black holes that could provide clues about extra dimensions and the nature of space-time. While it hasn't found them yet, the very fact that we can look for such things shows how seriously physicists take these ideas. If our universe is inside a black hole, then creating tiny black holes might be like creating tiny baby universes. But here's where things get really weird. If our universe can contain black holes and each black hole can contain a universe, then we have an infinite hierarchy of universes within universes. It's cosmic Russian dolls all the way down. The black holes in our universe might contain universes full of civilizations wondering if they're inside a black hole, while we're inside a black hole in a larger universe whose inhabitants are wondering the same thing. This isn't just philosophy, it has real, testable consequences. For instance, information that falls into a black hole in our universe might not be destroyed as Stephen Hawking worried. Instead, it might be preserved in the baby universe inside, just transformed in a way we can't access. This could solve the famous black hole information paradox that has puzzled physicists for decades. Recent observations from gravitational wave detectors LIGO and Virgo have given us new insights into black holes. When they detect black holes merging, They're potentially watching universes colliding and combining. The gravitational waves that ripple through our space-time might be birth cries of new cosmic babies being born in the violence of black hole mergers. The James Webb Space Telescope has been peering back to the earliest moments of our universe, seeing galaxies that formed just a few 100 million years after the Big Bang. Interestingly, some of these early galaxies look more mature than expected, as if our universe inherited some structure from its parents. This is exactly what we might expect if our Big Bang was actually a transit through a black hole's singularity. Dr. Raj Pathria and others have calculated that if our universe is inside a black hole, the parent black hole would need to have a mass of about 10 to the power of 23 solar masses. That's unimaginably huge, but in an infinite parent universe, such massive black holes could certainly exist. In fact, they'd be inevitable given enough time. The idea also provides a new perspective on dark energy, the mysterious force causing our universe's expansion to accelerate. In the black hole universe model, dark energy might be related to the rotation of the parent black hole. As matter inside the black hole spreads outward due to centrifugal effects, it would appear to us as accelerating expansion. This connects to another mind-blowing possibility. The holographic principle, developed by physicists Gerard 't Hooft and Leonard Susskind, suggests that all the information in our three-dimensional universe might be encoded on a two-dimensional surface, perhaps the event horizon of the black hole we're inside. We might literally be living inside a cosmic hologram. The evidence from string theory supports this too. String theorists have found that the mathematics describing the interior of certain black holes is identical to the mathematics describing certain universes. This ADS-CFT correspondence, discovered by Juan Maldacena, is one of the most important discoveries in theoretical physics of the past 30 years. But let's step back and think about what this means for you right now reading these words. If we're inside a black hole, it changes nothing and everything simultaneously. Your daily life continues exactly as before. Coffee still tastes like coffee, gravity still pulls things down, and the laws of physics work just as they always have. Yet philosophically, it transforms our entire understanding of existence. Consider the implications for time. Inside a black hole, time and space can switch roles. What we experience as time moving forward might actually be our universe falling through the spatial dimension of a higher dimensional black hole. This could explain why we can move freely through space, but are locked into moving forward through time. It's a consequence of our universe's geometry within the parent black hole. Dr. Claude Barabès and Dr. Valery Frolov have shown mathematically that the interior of a rotating black hole could undergo inflation, exactly the kind of rapid expansion our universe experienced in its first fraction of a second. Their equations, published in Physical Review D, demonstrate that the conditions inside a Kerr black hole naturally lead to an inflationary universe like ours. This inflation would smooth out any irregularities from the parent universe, explaining why our cosmos looks so uniform in all directions. It's like how a balloon becomes smoother as you inflate it. The rapid expansion erases the wrinkles. The cosmic microwave background's near-perfect uniformity, confirmed by the WMAP and Planck satellites, fits perfectly with this picture. The black hole universe theory also offers a stunning resolution to the question of what came before the Big Bang. In standard cosmology, this question is meaningless. Time itself began with the Big Bang. But if our universe emerged from a black hole, then before our Big Bang, there was the parent universe, with its own history, its own civilizations, its own story stretching back for who knows how long. Think about the profound shift in perspective this represents. Instead of our universe being all that exists, it becomes one bubble in an infinite foam of universes, each born from black holes, each potentially giving birth to countless more. The cosmic family tree has no beginning and no end, just an eternal branching of realities, creating realities. Recent work by Dr. Igor Novikov and others has explored whether information could travel between parent and child universes. While the event horizon prevents direct communication, quantum effects might allow subtle influences to pass through. Some physicists speculate that what we call the laws of physics might be partially inherited from our parent universe, like cosmic DNA passed from one generation to the next. The Laser Interferometer Space Antenna, or LISA, scheduled for launch in the 2030s, will detect gravitational waves from supermassive black hole mergers across the universe. If our universe is inside a black hole, these observations might reveal patterns that confirm the theory. The way black holes ring when they merge could tell us about the deeper structure of space-time itself. Here's another piece of evidence: the universe's entropy. The second law of thermodynamics says entropy always increases, and black holes have maximum entropy for their size. If our universe is inside a black hole, it would naturally have very high entropy, which is exactly what we observe. The entropy of our observable universe is about 10 to the power of 102, remarkably close to what we'd expect for a black hole of its size. Dr. Razieh Pourhassan and colleagues have calculated that if you trace our universe's expansion backward, instead of reaching a singularity, you reach a minimum size before bouncing back out. This bounce corresponds to passing through the black hole's singularity into our expanding universe. It's like squeezing through a cosmic bottleneck that transforms a collapsing star into an expanding cosmos. But perhaps the most elegant aspect of this theory is how it deals with infinities. In standard Big Bang cosmology, we face the problem of an initial singularity, a point of infinite density and temperature where our equations break down. But in the black hole universe model, what looks like a singularity from outside is just a transition region from inside. The infinities disappear, replaced by finite but extreme condition. The European Extremely Large Telescope under construction in Chile will have the resolution to study black holes in unprecedented detail. By watching matter fall into black holes, we might glimpse the process that could have created our own universe. Every black hole we observe might be a cosmic womb nurturing a baby universe we can never directly see. This brings us to one of the most profound questions. If we're inside a black hole, can we ever know what's outside? The event horizon is a one-way boundary. Information can fall in but can't escape. Yet quantum mechanics suggests information can't be destroyed. This tension between general relativity and quantum mechanics might hold the key to understanding our cosmic situation. Stephen Hawking's discovery of Hawking radiation showed that black holes aren't perfectly black. They emit a tiny amount of radiation. If our universe is inside a black hole, we might be part of a vast quantum process, slowly evaporating back into the parent universe over unimaginable timescales. Our entire cosmic history might be just a quantum fluctuation in a larger reality. The mathematical framework supporting this cosmic inception goes even deeper. Dr. Lee Smolin's loop quantum gravity, a competitor to string theory, naturally predicts that black hole singularities are replaced by transitions to new expanding regions of space-time. In this view, the Big Bang wasn't a beginning but a quantum bounce from a previous collapsing state. This quantum bounce has been studied extensively by physicists like Martin Bojewald and Abhay Ashtekar. Their calculations show that quantum effects become dominant near what classical physics calls a singularity, preventing infinite density and instead creating a bridge to a new, expanding phase. It's like the universe has a built-in safety mechanism preventing true singularities. Observations from the Atacama Cosmology Telescope in Chile have mapped the cosmic microwave background with incredible precision. The patterns they see, tiny temperature fluctuations that seeded all cosmic structure, match what we'd expect from quantum fluctuations during a passage through a black hole's core. These primordial ripples might be fossil evidence of our universe's violent birth. But here's something that might blow your mind even more. Time itself might run differently in different parts of this cosmic hierarchy. In the parent universe, our entire cosmic history, all 13.8 billion years of it, might pass in just seconds near their black hole. Conversely, the universes inside black holes in our cosmos might experience billions of years while only moments pass for us. This time dilation effect isn't science fiction. It's an observed fact. GPS satellites have to correct for time dilation, or they'd give wrong positions. Near a black hole, the effect is extreme. If our universe is inside a black hole, we're living in a region of supremely warped time, though it feels normal to us because we're all warped together. Dr. Neerjesh Afshordi from the University of Waterloo has proposed that we might test the black hole universe hypothesis by looking for signatures in the cosmic microwave background. If our universe passed through a black hole singularity, it might have left subtle spiral patterns in the CMB that future missions could detect. We might literally see the fingerprints of our parent black hole painted across our sky. The idea also resolves puzzling coincidences in cosmology. For instance, the amount of dark energy in our universe is weirdly small but not zero, just right to allow galaxies to form before acceleration takes over. In the black hole universe model, this could be explained by selection effects. Only universes with the right amount of dark energy produce lots of black holes and thus lots of baby universes. Consider what this means for the ultimate fate of our cosmos. In standard cosmology, the universe faces heat death, endless expansion into a cold, empty void. But if we're inside a black hole, our universe's death might be another universe's birth. The black holes we create might be seeds of cosmic renewal, ensuring that complexity and life can arise again and again in an eternal cycle. The 30-meter telescope, when completed, will be able to peer deeper into space and time than ever before. It might see the very first black holes that formed in our universe, potentially the first cosmic eggs that could hatch new realities. Every black hole we discover might be a doorway to an entire cosmos we can never explore. This perspective transforms black holes from cosmic monsters into cosmic mothers. The supermassive black hole at the center of our galaxy, Sagittarius A star, with its 4 million solar masses, might contain universes within universes, each teeming with its own galaxies, stars, planets, and possibly life. We're surrounded by hidden realities we can never access, but that might be as rich and complex as our own. Dr. Leonard Suskind's work on the holographic principle adds another layer to this mystery. He's shown that all the information falling into a black hole gets encoded on its two-dimensional event horizon. If our universe is inside a black hole, then everything about our reality, including your thoughts right now, might be encoded on a distant boundary we can never reach. This isn't just abstract mathematics. The holographic principle has passed every test physicists have thrown at it. It correctly predicts the entropy of black holes, resolves paradoxes in quantum gravity, and might explain why space itself seems to be made of tiny, discrete units at the smallest scale, pixels in the cosmic hologram. Recent discoveries about black hole mergers from LIGO and Virgo add weight to these ideas. When black holes spiral together and merge, they ring like cosmic bells, sending gravitational waves across the universe. If each black hole contains a universe, these mergers might be the most violent events imaginable, entire realities colliding and combining in seconds. Dr. Carlo Rovelli, one of the founders of loop quantum gravity, has calculated that information falling into a black hole might tunnel through to emerge in the baby universe inside. This quantum tunneling would be incredibly rare, but over cosmic timescales, it could transfer significant information from parent to child universe. We might carry encoded messages from our parent cosmos without knowing it. Think about the philosophical implications. Every choice that creates a black hole in our universe might birth an entire reality. When a massive star decides to collapse rather than explode, it might be choosing to create trillions of future civilizations. The universe becomes a living, breathing organism, constantly creating new versions of itself. The evidence keeps accumulating from unexpected directions. In 2021, physicists studying the distribution of galaxies found that they're arranged in a vast bubble structure, with our local group near the center of a void about 1 billion light-years across. This is exactly what we might expect if our universe inherited large-scale structure from the matter distribution around the parent black hole that birthed us. Dr. Damien Eason and colleagues have shown that black holes in our universe might already be creating baby universes with different physical laws. When matter collapses past a certain density, quantum effects could trigger inflation in a new region of space-time hidden behind the event horizon. Every second, new realities might be blooming inside the millions of black holes scattered throughout our galaxy. The Square Kilometre Array, the world's largest radio telescope now under construction, will map hydrogen gas throughout the universe with unprecedented precision. This cosmic census might reveal whether our universe's structure matches predictions from the black hole hypothesis. The way matter clumps and flows could tell us about the rotation and properties of our parent black hole. But here's a mind-bending twist. If universes can exist inside black holes, what about consciousness? Sir Roger Penrose, Nobel laureate in physics, has proposed that consciousness might be linked to quantum processes in space-time itself. If our universe is inside a black hole, could consciousness be a property that emerges from the special geometry of black hole interiors? This isn't as crazy as it sounds. Black holes are the only objects in nature where quantum mechanics and general relativity must work together. They're cosmic laboratories for the unified physics we're still trying to understand. The conditions inside a black hole might naturally give rise to the complexity needed for consciousness to emerge. Recent observations of fast radio bursts, mysterious flashes of radio waves from distant galaxies, have added another piece to the puzzle. Some physicists speculate these might be signals from matter transitioning through black hole singularities into new universes. We might be detecting the birth cries of baby cosmos being born right now across the universe. The black hole universe model also explains why our universe seems to have a beginning. From inside, the Big Bang looks like the start of everything, but from outside it's just matter falling through an event horizon, a process that happens countless times throughout the parent universe. Our cosmic origin story becomes one chapter in an infinite book. Dr. Stefan Alexander from Brown University has proposed that the fundamental forces of nature might have separated during our universe's passage through the black hole's singularity. The extreme conditions could have broken the symmetry of a unified force, creating the distinct forces we see today: gravity, electromagnetism, and the strong and weak nuclear forces. This symmetry breaking would have released enormous energy, driving cosmic inflation and creating the matter-antimatter asymmetry that allowed our universe to exist. The black hole transition might be the cosmic forge where the laws of physics themselves are shaped and reshaped with each new universe. Consider what this means for the search for a theory of everything. Physicists have spent decades trying to unify quantum mechanics and general relativity. But if we're inside a black hole, the solution might require understanding physics across multiple universes. The theory of everything might actually be a theory of every universe. The Vera Rubin Observatory, beginning operations soon, will survey the entire visible sky every few nights, catching transient events we've never seen before. It might spot the signatures of new universes being born in real time, perhaps unusual gamma-ray bursts or gravitational wave patterns that mark black hole singularities transforming into Big Bangs. But perhaps the most profound implication is for the nature of existence itself. If every black hole contains a universe, then existence isn't rare or special. It's inevitable. Given enough time, every possible universe will be realized somewhere in the infinite hierarchy. Every story that can be told will be told. Every form of life that can exist will exist. This cosmic fecundity might explain the Fermi paradox, why we don't see evidence of alien civilizations. If universes are common, then civilizations might focus on creating new universes rather than colonizing their current one. Why spread across one cosmos when you can create trillions of new ones? Advanced civilizations might be cosmic gardeners, cultivating black holes to seed new realities. Dr. Sean Carroll from Johns Hopkins University has calculated that creating a black hole to birth a new universe might be surprisingly easy for an advanced civilization. You'd need to compress matter to extreme densities, but not impossibly so. Our descendants might one day create designer universes with custom physical laws, becoming gods of their own realities. The black hole universe hypothesis also sheds new light on quantum mechanics. The many worlds interpretation says every quantum event branches into multiple realities. If we're inside a black hole, these branches might be realized as actual baby universes spawned by quantum fluctuations. What we call parallel worlds might be sibling universes born from the same parent black hole. Recent studies of black hole thermodynamics by physicists like Ted Jacobson have shown that Einstein's equations of general relativity can be derived from thermodynamic principles applied to event horizons. If our universe is inside a black hole, then the laws of physics themselves might emerge from the statistical behavior of information on the cosmic horizon. This thermodynamic origin of gravity has profound implications. It suggests that what we experience as the force of gravity might actually be an entropic force, like the tension in a rubber band that emerges from the statistical behavior of its molecules. If we're inside a black hole, gravity itself might be a consequence of information processing on the cosmic event horizon surrounding us. The Nanograv collaboration has been using pulsars as cosmic clocks to detect gravitational waves with wavelengths spanning light years. They've found hints of a gravitational wave background that could come from countless supermassive black hole mergers throughout cosmic history. Each merger might represent universes combining, their physical laws blending like cosmic DNA, mixing in reproduction. Dr. Andre Linde from Stanford, one of the fathers of inflation theory, has shown that eternal inflation naturally creates a multiverse where different regions have different physical properties. If our universe is inside a black hole, eternal inflation might be happening in the parent universe, constantly creating new black holes and new realities. We might be one bubble in an eternally fizzing cosmic champagne. But here's where it gets even stranger. Time might not flow the same way in all these universes. While we experience time as flowing from past to future, universes inside rotating black holes might experience time differently. Some might have multiple time dimensions. Others might have closed time-like curves allowing travel to the past. The black hole transition might scramble the very meaning of before and after. The cosmic microwave background contains tiny anomalies that don't quite fit the standard model. The axis of evil, a mysterious alignment of temperature fluctuations, and the cold spot, An unusually large, cool region might be scars from our universe's birth through a black hole. They could be cosmic stretch marks from our violent passage through the singularity. Dr. Laura Mersini-Houghton from the University of North Carolina has proposed that these anomalies are evidence of other universes tugging on ours through quantum entanglement. If we're all inside black holes in a parent universe, we might be quantum mechanically connected to our sibling universes, other black holes in the same parent cosmos. This quantum entanglement between universes could explain dark matter and dark energy. What we perceive as invisible matter and energy might be the gravitational influence of sibling universes connected to ours through the quantum foam. We might be feeling the pull of realities we can never see, but that share our cosmic ancestry. Recent advances in quantum computing might let us test these ideas. By creating quantum simulations of black hole interiors, we could explore what happens when matter passes through singularities. IBM, Google, and other tech giants are building quantum computers powerful enough to model these cosmic transitions. We might discover the birth process of universes in a laboratory. The black hole universe model also offers a new perspective on fine-tuning. Our universe's constants seem precisely calibrated for complexity and life. In a multiverse of black hole universes, this isn't surprising. We naturally find ourselves in a universe capable of supporting observers. The universes that can't support life have no one to wonder about their existence. But it goes deeper than anthropic selection. If universes reproduce through black holes, and black holes require stars, and stars require certain physical constants, then there's cosmic evolution toward life-friendly universes. Life isn't an accident, it's an inevitable consequence of cosmic reproduction. The universe doesn't just permit life, it's optimized to create it. Dr. Clifford Johnson from USC has shown that string theory naturally describes transitions between different space-time geometries. Exactly what would happen when passing through a black hole into a new universe. The extra dimensions of string theory might be the cosmic birth canal through which new universes are born, each with its own compactification of the higher dimensions. The Large Synoptic Survey Telescope will catalogue billions of galaxies, creating a three-dimensional map of the universe more detailed than ever before. This cosmic census might reveal whether our universe's large-scale structure matches what we'd expect from birth inside a rotating black hole. The distribution of galaxy clusters could encode information about our parent black hole's spin and mass. Think about what this means for meaning and purpose. If our universe is one of countless others, does that diminish our significance or enhance it? I'd argue it enhances it. We're part of a cosmic reproductive cycle that ensures complexity and consciousness arise again and again. Every moment of beauty, love, and discovery in our universe contributes to a pattern that echoes across infinite realities. The black hole universe hypothesis also suggests a cosmic form of immortality. While individuals die and civilizations fall, the patterns they create, the art, science, and wisdom they develop, might influence the formation of new universes. Information falling into black holes in our universe might seed the physical laws and constants of baby universes. We might be unconsciously programming future realities. Dr. Paul Davies from Arizona State University has proposed that life might play an essential role in cosmic reproduction. Intelligent civilizations might create black holes with properties optimized for spawning life-friendly universes. We could be part of a cosmic feedback loop where life creates conditions for more life across multiple universes. The cosmos might be consciously cultivating consciousness. This cosmic cultivation of consciousness takes on new meaning when we consider recent discoveries about quantum biology. Scientists have found that quantum effects play crucial roles in photosynthesis, bird navigation, and possibly even human consciousness. If life harnesses quantum mechanics and quantum mechanics governs the birth of universes from black holes, then life and cosmos are intimately entangled at the deepest level. The Event Horizon Telescope continues to image black holes across the universe. Each new image might be an ultrasound of a pregnant universe. The glowing accretion disks we see could be cosmic, amniotic fluid, nurturing realities we can never visit. When we study black holes, we're potentially studying the wombs of creation itself. Dr. Max Tegmark from MIT has classified different levels of multiverse, and the black hole universe fits into what he calls Level 2, regions with different physical constants separated by cosmic inflation. But it might also connect to Level 3, the quantum many-worlds, if each quantum event inside a black hole spawns a slightly different baby universe. We might be living in a cosmic fractal where every scale reveals new layers of reality. Recent observations of gravitational lensing, where massive objects bend light from distant sources, have revealed that dark matter forms vast cosmic webs connecting galaxies. If we're inside a black hole, this web might reflect the structure of matter falling into the parent black hole. We might be seeing the shadow of our parent universe's architecture imprinted on our own. The Breakthrough. Listen Project searches for signs of extraterrestrial intelligence by monitoring millions of stars for artificial signals. But if advanced civilizations create baby universes, they might communicate by encoding messages in the physical constants of those universes. The fine structure constant, the proton-to-electron mass ratio, these might be cosmic zip codes telling us about our parent civilization. Dr. Seth Lloyd from MIT has shown that black holes are the ultimate computers, processing information at the maximum rate allowed by physics. If our universe is inside a black hole, then we're living inside a cosmic computer. Every physical process, from atomic interactions to galactic collisions, might be computations in this vast machine. Reality itself might be information processing. This computational view connects to the simulation hypothesis, the idea that our reality might be artificial. But in the black hole universe model, we're not simulated by some external computer. We're a natural computation running on the hardware of space-time itself. The universe doesn't run on a computer. The universe is a computer. The Chandra X-ray Observatory has detected supermassive black holes in the early universe that seem too big to have grown from stellar collapse. They might be primordial black holes formed directly from the conditions of the Big Bang, or rather from our passage through the parent black hole. These cosmic giants might be inherited from our parent universe like cosmic heirlooms. But what about the beginning of it all? If every universe comes from a black hole in a parent universe, how did the first universe begin? This infinite regress might seem problematic, but it's no worse than asking what came before the Big Bang in standard cosmology. Perhaps there is no first universe, just an eternal chain of cosmic creation with no beginning and no end. Dr. Roger Penrose's conformal cyclic cosmology offers another perspective. He proposes that what we call the Big Bang is actually the infinite future of a previous universe, rescaled through a mathematical transformation. Black holes might be the mechanism for this rescaling, transforming the cold, empty future of one universe into the hot, dense beginning of the next. The Ice Cube Neutrino Observatory at the South Pole detects ghostly particles that pass through entire planets without interacting. Some of these high-energy neutrinos might come from matter falling into black holes and transitioning to baby universes. We might be detecting the birth announcements of new realities written in the language of fundamental particles. Consider the implications for free will and determinism. If our universe's laws were set by conditions in the parent black hole, are we living out a predetermined script? Not necessarily. Quantum mechanics ensures that even with fixed laws, the future remains genuinely open. Each universe might be a jazz improvisation on themes inherited from its parent, structured but spontaneous. The black hole universe model also revolutionizes our understanding of cosmic death. In standard cosmology, the universe faces heat death, a state of maximum entropy where nothing interesting can happen. But if black holes birth new universes, then entropy can be reset. What looks like death from inside becomes birth from outside. The cosmos has discovered immortality through reproduction. Dr. Juan Maldaceno's discovery of ADS-CFT correspondence shows that a gravitational theory inside a space can be exactly equivalent to a quantum theory on its boundary. If we're inside a black hole, our four-dimensional universe might be equivalent to a three-dimensional quantum theory on the event horizon. We might be living in a cosmic hologram more literally than we ever imagined. Recent studies of quantum error correction have revealed that space-time itself might be a quantum error-correcting code. The geometry of space might be nature's way of protecting quantum information from decoherence. If we're inside a black hole, the curved space-time around us might be a cosmic error correction mechanism, ensuring that information about our parent universe is preserved and transmitted. This quantum error correction in space-time has been demonstrated mathematically by physicists like Daniel Harlow and John Preskill. They've shown that the holographic principle naturally implements quantum error correction, with the bulk space-time protecting information encoded on the boundary. If our universe is holographically encoded on a black hole's event horizon, then the very fabric of reality might be a cosmic backup system preserving information across universal generations. The Dark Energy Survey has mapped millions of galaxies to understand cosmic acceleration. Their data shows that dark energy behaves almost exactly like Einstein's cosmological constant, but with tiny deviations that might be signatures of our universe's birth inside a black hole. The slight variations in dark energy density across the sky could reflect the asymmetric conditions of our cosmic birth canal. Dr. Sabine Hossenfelder from the Frankfurt Institute has proposed that if we're inside a black hole, we should see specific patterns in the cosmic microwave background radiation. These patterns would come from the rotation and charge of the parent black hole, imprinted on our universe like a cosmic birthmark. Future missions like the Simons Observatory might have the sensitivity to detect these subtle signatures. But here's a troubling thought. If creating black holes creates universes, what happens when we create microscopic black holes in particle accelerators? The Large Hadron Collider hasn't produced them yet, but future colliders might. Would we be creating universes? And if so, what moral obligations would we have toward the potential civilizations inside them? This ethical dimension becomes even more complex when we consider that advanced civilizations might engineer black holes to create designer universes. They could adjust the mass, spin, and charge to fine-tune the resulting universe's properties. We might be living in a universe deliberately crafted by our parent civilization to maximize beauty, complexity, or consciousness. The Nanograv Pulsar Timing Array has detected what might be gravitational waves from the early universe, not from individual events, but from the cosmic gravitational wave background. If we're inside a black hole, these primordial gravitational waves might carry information about our violent birth, like cosmic DNA encoding our universe's properties. Dr. Kip Thorne, Nobel laureate for his work on gravitational waves, has shown that traversable wormholes might exist if exotic matter with negative energy density is available. If our universe is inside a black hole, such wormholes might connect us not to distant parts of our universe, but to sibling universes, other black holes in the same parent cosmos. Interuniversal travel might be theoretically possible. Recent quantum experiments have demonstrated that time can flow backward at the quantum scale under certain conditions. If our universe emerged from a black hole singularity where quantum effects dominate, some regions might have experienced reverse time during the transition. This could explain matter-antimatter asymmetry. Antimatter might have been swept into regions with reversed time. The laser interferometer space antenna will detect gravitational waves from supermassive black hole mergers across cosmic history. Each merger might represent not just the collision of black holes, but the unification of entire universes. The gravitational wave signatures could tell us how physical laws blend when universes merge. Do they average out? Does one dominate? Or do they create something entirely new? Think about what this means for the ultimate limits of knowledge. In standard cosmology, we can never see beyond the cosmic horizon or before the Big Bang. But if we're inside a black hole, these limits are even more fundamental. The event horizon doesn't just limit what we can see, it defines the boundary of our reality. Yet through physics and mathematics, we can still reason about what lies beyond. Dr. Carlo Rovelli's relational quantum mechanics suggests that reality doesn't exist independently, but only in the relationships between systems. If our universe is inside a black hole, it exists only in relation to the parent universe, yet that relationship is severed by the event horizon. We might be cosmically orphaned, cut off from our parent reality by the ultimate boundary. The 30-meter telescope will study the first stars and galaxies with unprecedented clarity. If our universe inherited any structure from its parent, these primordial objects might show it. The first stars might be arranged in patterns that reflect the matter distribution around the parent black hole at the moment of our birth. We could be seeing fossilized remnants of another reality. But perhaps the most mind-expanding implication is that consciousness itself might be fractal across universes. If consciousness emerges from information processing and universes inside black holes process information, then awareness might exist at every scale, from individual minds to entire universes. We might be thoughts in a cosmic mind that is itself a thought in an even larger mind. Dr. Giulio Tononi's integrated information theory proposes that consciousness corresponds to integrated information, the amount of information generated by a system above and beyond its parts. A universe inside a black hole, with its complex interactions between matter, energy, and space-time, might have tremendous integrated information. The cosmos itself might be conscious. Recent discoveries in neuroscience show that the brain's neural networks have a fractal structure remarkably similar to the cosmic web of galaxies. This isn't just coincidence. Both systems might be optimizing information flow using the same mathematical principles. If we're inside a black hole, this similarity might reflect a deeper unity between mind and cosmos. The James Webb Space Telescope has revolutionized our view of the early universe, finding massive, mature galaxies that shouldn't exist so soon after the Big Bang. If our universe emerged from a black hole, these impossible galaxies make sense. They might have inherited structure from matter falling into the parent black hole. The cosmic seeds were pre-planted before our universe even began. Dr. Erik Verlinde from the University of Amsterdam has proposed that gravity itself might be an emergent phenomenon arising from quantum information. In his theory, what we call dark matter is actually the effect of quantum entanglement across cosmic scales. If we're inside a black hole, this entanglement might extend to our sibling universes, creating a cosmic family bound by quantum ties we perceive as missing matter. The Cosmic Web Imager at Palomar Observatory has directly observed the filaments of gas connecting galaxies, the cosmic web made visible. These filaments trace the large-scale structure of our universe, but they might also trace the path matter took falling into our parent black hole. We might be seeing the fossilized trajectory of our own cosmic birth. Consider what this means for the arrow of time. In our universe, time flows from past to future, from low entropy to high entropy. But this arrow might have been set by our passage through the black hole. The parent universe's future became our past. Time's direction might be as arbitrary as which way is up, determined only by your perspective. The IceCube neutrino detector has found high-energy neutrinos from outside our galaxy, including some from the direction of blazars, supermassive black holes shooting jets directly at us. These neutrinos might carry information about universe creation happening right now. Each detection might be a birth announcement from a cosmos being born. Dr. Leonard Susskind has shown that black holes are the fastest scramblers of information in nature. They mix up information more quickly than any other physical system. If our universe is inside a black hole, this scrambling might explain why we can't access information about our parent universe. The passage through the singularity scrambled everything like a cosmic blender. But some information might survive. Recent work on black hole information paradox suggests that information isn't destroyed but is encoded in subtle correlations in Hawking radiation. If our universe is inside a black hole, we might be part of that encoding. Every particle in our universe might carry a tiny piece of information about the parent reality. The square kilometer array will map the distribution of hydrogen throughout cosmic history. This most abundant element traces cosmic structure from the first stars to today. If we're inside a black hole, the distribution of hydrogen might encode information about rotation, charge, and mass of our parent black hole. Cosmic vital statistics written in the simplest element. Dr. Raphael Busso from UC Berkeley has developed the covariant entropy bound, a limit on how much information can exist in any region of space-time. This bound is saturated by black holes which pack the maximum information possible into their event horizons. If our universe is inside a black hole, we're living at the maximum information density allowed by physics. This information density connects to the nature of space itself. Loop quantum gravity suggests space is made of tiny loops at the Planck scale, 10 to the negative 35 meters. These loops might be the pixels of reality, and their arrangement might encode our universe's birth conditions. Space itself might be a cosmic hard drive storing our origin story. Recent observations of fast radio bursts have revealed that some repeat in patterns that seem almost artificial. While probably natural phenomena, they raise an intriguing possibility. If advanced civilizations can create universes, might they also send signals between them? Could some cosmic phenomena be messages from our parent universe or signals between sibling universes? The Breakthrough Starshot project aims to send tiny spacecraft to nearby stars using powerful lasers. But Dr. Avi Loeb from Harvard has suggested that similar technology could be used to create small black holes that spawn baby universes. Our descendants might become cosmic gardeners, planting seeds of new realities among the stars. Think about the philosophical implications of existing inside a black hole. We're used to thinking of black holes as endpoints, places where things disappear forever. But if they're actually birthplaces of new universes, then what seems like death from one perspective is birth from another. The universe has found a way to make endings into beginnings. This perspective transforms our understanding of cosmic purpose. If universes reproduce through black holes, and if consciousness tends to arise in universes, then the cosmos might be evolving toward ever greater consciousness. We're not accidents in an indifferent universe. We're part of a cosmic awakening that spans multiple realities. Dr. Stuart Kaufman has proposed that the universe naturally evolves toward the adjacent possible configurations just beyond current reality. If universes reproduce through black holes with slight variations, they're constantly exploring the space of possible physics. Our universe might be one experiment in an infinite cosmic laboratory. The Dark Energy Spectroscopic Instrument is creating the largest 3D map of the universe ever made. By measuring how cosmic expansion has changed over time, it might detect signatures of our universe's birth inside a black hole. The way dark energy evolves could tell us about our cosmic heritage. As we approach the end of this cosmic journey, let's consider what all of this means for humanity's future. If we're inside a black hole, and if black holes birth universes, then creating black holes might be the ultimate act of cosmic creativity. Instead of spreading across one universe, advanced civilizations might create countless universes, each an experiment in different physical laws and possibilities. Dr. Alan Guth, who developed inflation theory, has calculated that creating a universe might require surprisingly little energy, perhaps only a few kilograms of matter compressed to the Planck density. This means that universe creation might be within reach of civilizations only slightly more advanced than ours. Your descendants might literally become creators of the cosmos. The recent discovery of phosphine in Venus's atmosphere, though still debated, reminds us that life might exist in places we never expected. If our universe is inside a black hole, life might be even more prevalent than we imagine. Each black hole might harbor universes teeming with life, creating a fractal tree of consciousness spreading through dimensions we can barely imagine. Dr. Freeman Dyson proposed that advanced civilizations might build spheres around stars to harvest their energy. But if universes can be created inside black holes, why stop at stellar engineering? Ultimate civilizations might engage in cosmic engineering, crafting universes with physical laws optimized for consciousness, beauty, or purposes we can't even conceive. The holographic principle tells us that all the information in our universe might be encoded on its boundary. If we're inside a black hole, that boundary is the event horizon. Every thought you've ever had, every memory you hold dear, every moment of love or loss, it's all written on a cosmic screen we can never reach, but that defines everything we are. Recent advances in quantum computing have brought us closer to understanding how information behaves at the quantum level. Companies like IBM and Google are building machines that exploit quantum superposition and entanglement. These same principles might govern how universes inside black holes inherit properties from their parents. We're building tools that might let us understand our own cosmic birth. Dr. Lisa Randall from Harvard has proposed that our universe might have extra dimensions beyond the 3 spatial dimensions we experience. If we're inside a black hole, these extra dimensions might be how we're connected to the parent universe. Gravity might be weak in our universe because it's diluted across these extra dimensions, leaking into the parent cosmos. The Euclid Space Telescope, launched by the European Space Agency, is mapping the geometry of the universe with unprecedented precision. Its measurements of how space curves and expands might reveal whether our universe has the exact geometry expected from birth inside a rotating black hole. We might finally read our cosmic birth certificate. But here's perhaps the most profound realization. If our universe is inside a black hole, and if consciousness is a natural emergent property of complex information processing, then awareness might exist at every level of reality. The parent universe might be conscious, our universe might be conscious, the universes inside black holes in our cosmos might be conscious. It's consciousness all the way down and all the way up. This cosmic consciousness isn't mystical. It's a natural consequence of information integration at different scales. Just as your consciousness emerges from neurons without any single neuron being conscious, cosmic consciousness might emerge from the interaction of galaxies, stars, and planets without any single component being aware. Dr. Christoph Koch, a leading consciousness researcher, has proposed that any system with integrated information has some degree of consciousness. If our universe is inside a black hole, it's the ultimate integrated system, every particle connected to every other through the fabric of space-time. The universe doesn't just contain consciousness, the universe is conscious. As we stand on the threshold of becoming a spacefaring civilization, this perspective offers both humility and hope. Humility because we're infinitesimally small parts of an infinitely vast cosmic structure. Hope because we're participants in a cosmic process that ensures consciousness and complexity arise again and again across infinite realities. The very atoms in your body have been on an incredible journey, forged in the nuclear furnaces of dying stars, scattered across space in supernova explosions, gathered by gravity into new stars and planets, and finally assembled into you, a conscious being capable of understanding this entire story. If we're inside a black hole, your atoms might continue their journey into new universes, becoming part of future civilizations we can't imagine. Every black hole we observe might be a doorway to infinity. The supermassive black hole at the center of our galaxy, the stellar black holes scattered throughout space, even the primordial black holes that might make up dark matter. Each one might contain universes as vast and complex as our own. We're surrounded by hidden infinities we can never explore, but that might be as real as the world around us. So what if our universe is inside a black hole? It changes everything and nothing. Your morning coffee still tastes the same. The sun still rises and sets. Love, beauty, and meaning remain. But now you know that you might be part of something even grander than one universe. An infinite cascade of realities creating realities, each one a unique experiment in what can exist. Look up at the night sky with new eyes. Those points of light aren't just stars, they're furnaces forging the elements of future universes. That darkness between the stars isn't empty, it might be filled with invisible doorways to other realities. And you, looking up in wonder, are the universe understanding itself? A cosmic eye opened inside a black hole, gazing out at infinity and finding it gazing back. This is the ultimate cosmic perspective. We might be thoughts in a dreaming cosmos that is itself a dream in an even larger cosmos, dreams within dreams without beginning or end. And in this infinite hierarchy of existence, every level matters, every consciousness is precious, and every moment of awareness is a victory against the darkness. You are the universe experiencing itself, and that experience continues beyond any boundary we can imagine. If you are still watching, make sure to subscribe and give a thumbs up. Your support means a lot to me. And if you enjoyed this video, I am sure you will love this other one at the left side of the screen. What will happen when the Milky Way collides with Andromeda? In this video, discover the incredible science behind the future collision of the Milky Way and Andromeda galaxies, a cosmic event that will reshape our local universe. See you there.